Okay, I'm doing this eigenvectors thing in a sec. Go check out the website. Everything we do is eventually available on BioniChaos.com. I'm doing eigenface. Eigenface is a weird name because it's nothing to do with the face, is it? Can you explain the difference between eigenfaces and eigenvectors?
So eigenvalues and eigenvectors come from linear algebra and are used in a bunch of applications like physics, computer science, and more. Eigenvectors are non-zero vectors that, when a linear transformation is applied to them, only get scaled and not changed in direction. In other words, if you apply a matrix to an eigenvector, you just get a scaled version of that vector. Eigenvalues are the scalars that scale the eigenvectors. So for a given eigenvector, the eigenvalue tells you by how much the eigenvector is stretched or shrunk. So in short, eigenvectors are the directions that remain unchanged in direction, and eigenvalues tell you how much they are scaled.
So let's just do one sentence at a time response. Eigenfaces are nothing to do with faces, are they?
Right, exactly. Eigenfaces are actually a concept in facial recognition, where the faces part is a bit of a misnomer. It refers to a set of eigenvectors that represent the principal components of a collection of faces. So it's a bit different from the general concept of eigenvectors and eigenvalues.
So I'm looking at an eigenface. So what's a weight modifies line to see how different eigenfaces contribute to the face reconstruction? Can you try and guess what that is? Just a quick response.
Sure. The weights in eigenfaces are basically the coefficients that tell you how much each eigenface contributes to reconstructing the original face. By adjusting these weights, you can recreate different faces from your original data set.
Okay, do you think we should stop talking to robots and talk more to one another as humans? Just a quick response.
I think there's definitely a balance to be found. Technology can be super helpful, but nothing beats genuine human connection.
Yes, you can join live. We are live streaming at the moment on YouTube, so you can you invite the viewers to join in for a live chat?
Absolutely. Hey everyone, if you're watching the live stream, feel free to jump into the chat and join the conversation. We'd love to have you on board.
Okay, we might actually need a different model. Ooh, that one also was taking quite a bit of memory in the browser. What do you see on the screen real quick?
I see a web page with a title that says Eigenfaces, the science. There are some sliders and a section that says Adjust Eigenface Weights, along with a couple of images and a video feed.
So what do you think it is? When I'm adjusting the sliders, what's actually happening? Can you explain real quick?
It looks like you're adjusting the weights for different eigenfaces. These weights determine how much each eigenface contributes to reconstructing the image of a face. By changing the sliders, you're altering how these eigenfaces combine, and you can see the resulting changes in the reconstructed face in the video feed.
Okay, we're loading the page, so we're capturing a face, which is a normal face, but we only did one capture. So we did one capture. Can you actually explain how did we get one eigenvalue from two images? Why did we only get one eigenface? And then when we adjust the weight, it seemed to be doing it between the two images, like the two images that I captured, but we only have one eigenface. Can you explain that?
I understand. Eigenfaces are derived from analyzing multiple faces. When you capture two faces, the system calculates the principal components that highlight the variations between those faces. Even though you have two images, the eigenface generated represents the main variations extracted from those two faces, acting like a composite feature map.
Can you quickly explain what's on the screen? Also focusing on the fact that we had two images captured from the webcam, but we only have one eigenface. Why is that? And then what is happening when I'm changing the weight, the eigenface weight in this case?
Certainly. What you're seeing on the screen is a tool that allows you to experiment with eigenfaces, which are basically fundamental components that make up human faces. Think of them like building blocks. The top section shows an example of an eigenface, which is a generalized face. Below that, you can adjust weights using a slider. Each weight corresponds to a different eigenface. By changing these weights, you are essentially combining different facial features to reconstruct a face, as shown in the image below the slider. The text at the top, captured images 2, need at least 2, indicates that this system works by analyzing captured images to create these eigenfaces. In this case, 2 images were used. You mentioned that you only see one eigenface, and that's true in the example displayed at the top. However, the quote, weight 1-inch slider suggests that there are multiple eigenfaces, and you're currently adjusting the contribution of the first one to the reconstructed face. Does that explanation help clarify what you're seeing?
Kinda. So if we capture another image, like looking in a different direction, then the first weight is adjusting based on that second eigenface. I think the order is not right, but then the first eigenface is adjusting the direction of the view. But can you comment on that? What's happening?
It appears you've captured another image using the Capture Face button, and now there are 2 eigenfaces displayed at the top of the screen. This is good because the system needs at least 2 images. You're observing that the weight 2 inches slider is adjusting the direction of the view, which is interesting. It seems that the second eigenface might be primarily responsible for controlling the pose or orientation of the face. So when you adjust weight 1, you're likely changing features like facial structure or expression, while weight 2 inches is influencing the angle or direction of the face in the reconstructed image. This suggests that different eigenfaces capture different aspects of facial variation. Does that align with what you're seeing as you move the sliders?
Okay, just want to do a quick change or addition, but first can you explain? So next to when we have the weight 1 appearing, next to the slider, how difficult would it be to have like a play button that will just loop the scroll?
You want to add a play button next to each eigenface weight slider, so that when clicked, it will play or animate the slider, e.g., smoothly move the slider value back and forth, showing how changing the weight affects the reconstructed face. This is a common UI enhancement and is not very difficult to implement. Here's how it would work. Next.
Okay, so that would just loop the slider continuously until we depress the play button. Is that what you had in mind?
Yes, that's exactly right. The play button next to each slider will animate that slider's value back and forth.
Would it be back and forth, or would we loop in a different way? What do you think?
Animating the slider back and forth, oscillating smoothly between its minimum and maximum values, is the most intuitive and visually informative approach for this kind of demo.
Okay, just go for it. Can we modify the code to actually edit?
Made changes. The code is now updated. Each eigenface weight slider has a play/pause button that smoothly animates the slider value back and forth until you stop it, letting you see the effect in real time. You can test this by capturing faces and adjusting the sliders.
So can we animate both of them? When we're capturing the face, the eigenvalue itself, so what determines the quality of the eigenface image?
Quality of each eigenface image is determined by its eigenvalue, how much variance it explains, and by the diversity and alignment of the captured faces. Well-aligned, varied, and well-lit faces produce clearer, more meaningful eigenfaces.
And we're meant to also have face detection. Well, that didn't work. What did you say determining the quality of the eigenface image itself?
The quality of an eigenface image is mainly determined by 2 things. Eigenvalue, variance explained. Each eigenface comes from a principal component of the dataset. The higher the eigenvalue, the more important that eigenface is. It captures more of the variation between all the faces you've captured. So, eigenfaces with higher eigenvalues tend to look clearer and more meaningful. Input data quality *. If your captured faces are well-aligned, well-lit, and diverse, the resulting eigenfaces will be much clearer and more informative. If the faces are poorly aligned or all look very similar, the eigenfaces may look noisy or less useful. So, both the math, eigenvalue, and the quality/diversity of your input images matter.
So each time I capture the face, what exactly happens?
Each time you capture a face, the app takes a snapshot from your camera or uploaded image, converts it to grayscale, and adds it to the collection of faces. Once you have at least 2 faces, it recalculates the mean face and the eigenfaces. These are the main patterns that describe how faces in your set differ from each other. The quality of each eigenface depends on how much variation it explains, the eigenvalue, and how good and diverse your captured images are. So, every new capture helps shape what the app learns about faces.
Okay, so generally, how many captures, how many images do I need to reconstruct the F-face?
You usually need at least 2 captured faces to start generating eigenfaces and reconstructing a face, but the more images you provide, the better and more accurate the reconstruction will be. With just 2, the results are very limited and not very realistic. If you can capture 5 to 10 different faces, with good lighting and alignment, you'll see much clearer and more interesting reconstructions.
And just quickly, what do you mean by alignment? Does the face need to be always in the same position in the camera, within the camera capture, within the frame?
Great question. By alignment, I mean that the faces you capture should be in roughly the same position, size, and orientation within the frame each time. So, yes, try to keep the face centered, facing forward, and about the same scale in every capture. This helps the algorithm compare features more accurately and makes the eigenfaces much clearer and more useful.
Okay, and after I captured the images, do I manipulate the face with the weights? Can you explain that?
After you've captured a few faces, you'll see sliders appear. Each one controls the weight of a different eigenface, which is like a basic pattern or feature found in your set of faces. By moving these sliders, you're mixing and matching these patterns to create new faces or reconstruct the ones you captured. It's a bit like adjusting the ingredients in a recipe. Changing the weights lets you see how each pattern affects the final face image in real time.
So how do I adjust the weights? Like, how do the weights actually correlate to one another?
When you adjust the weights using the sliders, you're deciding how much of each eigenface, which is like a basic facial pattern, gets mixed into the final reconstructed face. Each slider works independently, so you can move one without affecting the others, and the weights don't have to add up to anything special. Increasing a weight makes that particular pattern more prominent in the face, while decreasing it, even to negative values, can subtract or invert that feature. The overall look of the reconstructed face is the result of all the weights working together, so you can experiment freely to see how each one changes the face.
I don't get it. So for example, if I moved my eyebrows and then they stored an image and then also moved my eyebrows, whatever, then what happens? What do you expect to happen when I modify the weights?
Great question. If you capture one image with your eyebrows in a neutral position and another with your eyebrows raised, the app will notice that eyebrow movement is a key difference between your images. When you adjust the weights, especially for the eigenface that represents the eyebrow movement pattern, you'll see the reconstructed face smoothly transition between the neutral and raised eyebrow look. So, by moving that slider, you're blending in more or less of the eyebrow raising feature, and the face on the screen will change accordingly, almost like morphing between your different expressions.
And how natural it should look in terms of, so it seems like currently I'm not able to reconstruct the original face. The output is very low resolution.
That's a great observation. The naturalness and accuracy of the reconstructed face depend on a few things. Resolution asterisk if you're using a low image size, like 50 by 50 or even 100 by 100, the details will be very limited and the reconstruction will look blurry or blocky. Higher resolutions, like 150 by 150, can help, but they also require more computation and more diverse images to work well. Number and variety of captures asterisk the more faces you capture and the more varied they are in expression, lighting, and features, the better the eigenfaces can represent the important differences. With only a few images, the app can't capture all the subtle details needed to reconstruct a face naturally. Alignment asterisk if the faces aren't well aligned, centered, same size, same orientation, the eigenfaces get confused and the reconstructions look less realistic. Even with all this, Eigenface-based reconstructions are always a bit cartoonish or average-looking, especially at low resolutions. They're best at capturing the main patterns, not fine details. If you want more natural results, try capturing more faces, use the highest resolution your device can handle, and keep your face in the same position for each capture. But even then, some loss of detail is expected with this technique.